Good morning, Maddie. It's a beautiful mathematical day, and today's lesson is covering Chapter 6.
That's right, Addie. Put your thinking caps on because we've covered this chapter a long time ago.
For a warm-up, please complete numbers 2 and 3 on page 360. If you need help, raise your hand.
Answers will vary for question 2, but a quick example of what you could have done is 6 to 8. And number 3's answer is 4 to 1.
Great job. Now let's pick up the pace.
Let's go over to Cameron for a quick lesson on section 2 and 3.
I don't have section 2. I did section 3. This is section 3. I don't have one for section 2.
I didn't tell her that, but
Number 3's answer is 4 to 1.
Great job. Now let's pick up the pace. Section 2 is titled Use Proportions to Solve Geometry Problems. All you need to know in this section is the new properties. There's a reciprocal property that says if two ratios are equal, then their reciprocals are also equal. And the next one is if you interchange the means of a proportion, then you form another true proportion. And the last one is, in a proportion, if you add the value of each ratio's denominator to its numerator, then you form a new true proportion.
Thanks, Addie. Let's go over to Cameron for a quick lesson on section 3.
Section 6.3 is about similar polygons, and all you need to know is that similar polygons are two polygons that have corresponding angles and corresponding sides. So let's do this problem. Find the value of x. Mn over dE equals np over EF. So you'd plug in the numbers, and 12 over 9 equals 20 over x. And then you would multiply and divide, and x equals 15. Back to you, Addie.
Okay, thanks, Cameron. We are now halfway through the chapter, moving right along to section 4, Proving Triangles Similar by AA.
The vocabulary for this section is similar polygons. Similar polygons are corresponding angles that are congruent whose corresponding sides are proportional, which are called similar polygons.
Back to you, Cameron, for our first lesson on Section 4.
Section 4 is about proving triangles are similar by using the AA similarity postulate. So we're going to determine if these triangles are similar using the angle-angle postulate. And they are because of the triangle sum theorem, which is, so you would do 26 plus 90 plus E equals 180. And then you would subtract, and E would equal 64. So then the triangles are similar because of the AA similarity postulate. Back to Addie.
Okay, the next session we are going to do is 6.5. Prove triangles are similar by SSS and SAS.
The new vocabulary that you will need to know is ratio, which we've already talked about, proportion, which is kind of the same thing, and similar polygons, which was back in Section 4 as well. Now over to Cameron for a lesson on Section 5.
I don't have it.
Okay, we'll pause the video and
Okay.
then I'll skip over.
Okay, so
Okay,
now
so
erase
erase
that. And now this one you're just gonna...
Okay, Kenna, turn the sound down for this part.
6.5 is about proving triangles are similar by SSS and SAS. So our example problem is to find the value of x that makes ABC equal DEF. So first we're gonna plug in the numbers into the proportional formula, which would be 4 over 12 equals x minus 1 over 18. And then we would simplify to 4 times 18 equals 12, in parentheses x minus 1. And then 72 equals 12x minus 12. So then the answer would be x equals 7. Back to you, Maddie.
The next section is 6.6, using proportional theorems.
The vocabulary you'll need to know is the new one is corresponding angles, which is, we all know what those are. We learned about those in chapter 1, so yeah.
Now Cameron is going to explain that.
Section 6, yeah.
Section 6.6 is using proportionality theorems. Theorem 6.4 is triangle proportionality theorem. If a line parallel to one side of the triangle intersects the two other sides, then it divides the two sides proportionally. So what is the length of side RQ? RQ over QU equals RS over ST. And then you'd plug in the numbers, so it would be RQ over 9 equals 4 over 6. And then you would divide and multiply, and RQ equals 6. Back to you, Addie.
Thanks for watching.
Have a great rest of the day.